hopefully you guys are either ITSI users currently, or you're about to use ITSI, in which case either if you're currently a user, this information is going to be perfect for you. It's going to be lessons learned, some ideas you can try. If you're not currently a user, you're thinking about using ITSI soon, then hopefully this will give you ideas on keep your eyes open and some thoughts open on what you can do with ITSI. All right, so get going here. So what are we doing today? We're going to talk about the strategies and things you can do in ITSI to kind of do the whole Morpheus open your mind. ITSI, when you start using it out of the box, there's some things you can do with it, but it's not really obvious the extent or how much stuff you can do with it. Right? There's a lot of detailed and complex stuff that you can do in ITSI that is not necessarily obvious. So you guys are a bunch of Splunk users, and you know the kinds of queries that you guys can do in Splunk. And sometimes when you're using ITSI, it's not immediately obvious that the complexities of your regular Splunk searches, you can bring those over into ITSI. So we're going to be talking about that. We're going to talk about powerful KPIs. The way we use it at Fiserv, not a pharmaceutical company, a financial tech company. All right. At Fiserv, we do, want to make sure that anything that could break the system, anything that could take us down, we have a KPI for to make sure that we have a monitor for it. Right? So there's nothing in ITSI that we've come across that makes us go, oh, well, that thing, the way we want to monitor that is too complex for ITSI. We want to go a different direction. Right? So we're talking about that, about the lack of limitations there and how we've worked around maybe some first glance things that might look like a limitation at first in ways of blowing past there. We're going to be talking about supporting some maintenance windows. There's some limited support for that in ITSI. We're going to talk about that. And then we're also going to be talking about some really powerful custom alerting, and that's a really great part, and we'll get to at the end. My name is Peter Thomas. I'm in charge of application service monitoring for a portion of Fiserv that's responsible for digital banking. So for our clients that we run their banking websites for us. So logging onto a website, seeing your funds, transferring funds, seeing your account history. That's what we're doing. That's what our software does for our website and mobile devices. We run some of those in-house for our clients and our servers in charge of monitoring that stuff for you. All right, so first talk about what are the things that we should expect to get out of ITSI. We expect to eliminate all the time to assess the platform health. I know that's kind of like the sales speak for ITSI of like, oh, you implement ITSI and then you're just going to know everything about your system. Obviously, it's not going to know everything about your system, but I think we've come really close to fulfilling what that sales promise is and what you're going to be able to do from it. And we feel like we've come really close. When we log into ITSI, the Service Analyzer view, we're going to get a complete view of not just a single application or a particular set of servers. We go to one screen. We have a prioritized view of everything that could be wrong with our platform, with our entire business unit, and have that all in front of us. So it is able to deliver on that. We also expect less dependency on subject matter experts. When you're thinking about classic Splunk dashboards, for us, that was kind of our second generation of monitoring, and ITSI is kind of our third generation of monitoring. So what were the problems with the second generation? Well, the second generation is very dashboard heavy. If someone walks in the room and says, tell me, how healthy is our business unit right now? The answer to that is, aside from any alerts, depending on alerts to go, if you want to manually check that, you're scrolling through dashboard after dashboard. And inside each dashboard that you have for each of your platforms, you have panel after panel. And every panel there is some bit of subject matter expertise required. What does that panel mean? What is it measuring? Not only do you need to know what is it measuring, but how do I know if it currently is good or bad, right? What is the historical value for that? It really depends on puts too much pressure and expectation on your tier one service guys to be looking at that and know all those panels and what they mean and what's normal for all your applications. So ITSI helps us get away from that and requiring so much subject matter expertise at the tier one level. Right? We also want to see holistic alerts. So think of a really basic example. Now, hopefully we don't run out of hard drive space because we have the monitoring for it, but let's just say we do. If you run out of hard drive space on your application tier, then it's going to cascade. You run out of hard drive space on an application server. Now your web servers that use that application tier, they're starting to throw some HTTP errors, right? And so now you're starting to see failures. And those are going to cause alerts as well. Now that your web tier isn't behaving well, your synthetic logins, you're logging into your site every so many minutes to make sure their logins are okay. Maybe those start getting intermittent failures as they start hitting those servers which are routing your requests to that one. And now you have 3 different problems. They're all related to the same thing, right? And so in the classic Splunk enterprise world where you set up an alert for CPU and you set up an alert for drive space and you set up alert for your synthetic logging, those all might create 3 different alerts. Those 3 different alerts might end up getting routed to 3 different teams, and depending on the size of your organization, maybe to 3 different continents, right? And each of those guys are working that without the full context of what's going on. And what we've done with ITSI is set that up in such a way where a single platform having those 3 problems has 1 alert that fires from that. I'm going to show you how to do that. So you have 1 alert that goes out to a team, and that member will have that team member will have all 3 of those listed there, so they can see all 3 problems. They have full context of the issue, and they go, okay, clearly what's going on here is the hard drive issue is causing these other things. Let me fix that, right? And so you're reducing the number of tickets while at the same time increasing the amount of context that they have. We're also going to talk about, we'll skip over that. All right, so just to give you a size of a reference for the size of implementation. Currently, just for the business unit that I'm in, Fiserv is a big company, we have about 400 ITSI services and about 3,250 KPIs. So every 5 minutes, 3,250 KPIs are currently running and getting metrics. And that's something we could never really do. You know, that's way too many panels, right? And that's where we were getting panel overload. People can't be checking that many panels, right? So instead, we're having ITSI check that. ITSI knows how to see where compare all those to thresholds and then bring the problems up to us. So if we, in the old world, when you didn't know until if you had a problem with some obscure KPI until you got finally to the bottom and saw that one KPI in a panel, or maybe there's so many panels you could fit on a dashboard, you didn't even have that KPI there. With ITSI, it's okay to have a really esoteric or really uncommon type of metric captured. Like this metric almost never means anything useful, right? It almost never goes from, it's always 1 and it never goes to 2. Right? But what if it does go to 2 sometimes? You got to be monitoring it for that case. But I don't care every day to look at it and double check that it's at 1, right? I can just put it in ITSI. It'll be one of my hundreds or thousands of KPIs. And when that 1 is a problem, it turns red and goes to the top of my dashboard. That's right. Create a monitor for it once, create the KPI once, and never worry about it again until maybe one day, 2 years down the road, it goes red, and now you can respond to it. All right, so just a reminder for those that aren't familiar, the building blocks of ITSI, so we're talking the same terminology as we go through here. ITSI is built upon services. It's something that you care about. So what are the things you care about? I care about a tier of servers, right? My web tier, my application tier, my database. I care about the clients that I have. Right? For us financial institutions, I care about the clients and I want a first-class object to make sure my clients are healthy, right? I might care about other things that might not be non-obvious, a particular network connection to another data center that we have, right? The health of that network connection might be another service. Anything I care about, that's a service, right? The services are made up of KPIs. These are the things that we care about, that we use. These are the things that indicate the health of that service, right? So if I'm talking about a tier of servers, it's CPU, it's memory, it's drive storage. If it's a web servers, it would also include response time and error rate, maybe certificate status. Do I have certificates that are about to expire on there? Anything that I care about, right? I might have that on there. If it's a client, it might be the success or failure rate of their particular transactions that I pulled from a database, pulled into Splunk, or the synthetic logins I have to their website, right? So what is it you care about? Those are services. How do you determine the health of them? Those are your KPIs. And then if you want further level of detail, then you also have entities, right? And so in this case, for a tier of servers, that might be each server in that list, right? But it could be anything else. Entities can be anything, and I'll show you more about that later. All right, so now we can get into the details of this stuff. So the first thing here, as I talked about, when we're doing monitoring, it doesn't have to be an ITSI. It doesn't have to be strictly something simple like CPU or memory and stuff like that. Also, with the entities I talked about at the end before, it doesn't just have to be servers. ITSI, as you're using it, kind of drives you down to that. It makes a server as being the really obvious entity. But an entity can be anything you want. And also, an entity doesn't have to be pre-configured in ITSI. ITSI does have an ability for you to set up a first-class entity, But your search can return dynamic results, and ITSI will render that just the same as first-class entities. All right. So don't worry so much about first-class entities because you don't have to adhere to that. You can have dynamic entities, which is really powerful. So an example I have here is things like drive space, right? So I want to make sure that all my servers have drive space, right? So I need an entity for each of those. But the first thing you hit up against is the metric out of something like Windows Perfmon. It's going to tell you how much drive space you have free for the whole server, right? Well, that's a problem if I have two drives, and one drive says I have a terabyte of free space, and the other drive has no free space, and it's going to say, you have a terabyte of free space, right? That's not quite good enough. Well, I need to know that one of those drives is low on space. So I need an entity, not just per server, but I need an entity per drive and per server, right? So in this case, you see here the simple query on the bottom, and with a simple little addition here, we can create a new field called drive host in this case, and we've concatenated those two things together. So now for every metric that I have, I've created a new field called host, or called drive host, which concatenates host and the instance together. And then now I can split on that field. Instead of splitting on the host, I can split on drive host, and that'll get us results that look something like this. All right. So the great thing about this is that as you add more servers or you add more drives to any of them, it'll automatically show up here. You don't need to set up every drive or every server as a first-class entity. You can if you want to, but that's a lot of maintenance work. You don't need to. Right? So by splitting on made-up entities like this, on made-up fields, what are some of the kinds of things? Real quick, this is how it would look like in the configuration of that. So you can see our query up above. We can see where we're splitting. We choose what entity we want to split by. Instead of splitting by host, which is what it'll fill in there by default most of the time, a lot of times you want to split by host, but not every time, right? So you can say I want to split by drive host, right? And then further down, you can filter that data by entities. We'll talk a little bit more about that later. It's a separate piece of configuration. It's not really relevant to this particular example. All right, so thinking about that, what else might you want to split on when you're monitoring data, when you're monitoring feeds? So another thing you might want to do, which we do, is have a separate network monitoring tool that is capturing all the outbound traffic from our servers to all different URLs. So in this case, it's B2B traffic, right? So we have a server that's making calls to a fixed number of services. And we want to make sure that that's all healthy, right? So we might have a KPI that says, tell me the response time, the average response time to all our outbound endpoints that we call, right? Now, I'm not on the application side, and I don't know when the application team adds a new endpoint that they start making outbound calls to. I don't want to have to be maintaining that in ITSI, right? I don't want to have to be knowing that they added that we're now calling some other service, right? But you don't have to. If we see all the traffic and we're just split by whatever the URLs are, we can do that, right? So some other examples, you might do that by seeing the traffic by, let's say you have database records for audit records, and here's represents transactions for clients. And if you have an ASP platform, of which we do, you might want to split that data by each client, right? So you could have a single KPI that is the success rate of transactions by client, right? And as you add new clients or decommission them, you automatically have that. You don't have to maintain that, right? So using dynamic entities is very powerful for getting visibility into a lot of stuff. All right. So let's get even more complex, and it's going to get real complex. I apologize. So we'll get a little more complex here. All right. So what if we want to do something like an important KPI for us is we want to make sure that the traffic to all our web servers is balanced, right? We're using load balancers. We expect that to be the case. If we're receiving more traffic on one server than the others, or less traffic on that server than the others, I want to capture that. Right? I want to know that that's happening. And there's nothing about ITSI that prevents you from doing that. Whatever your use case is for this query means that my system is healthy, there's nothing to prevent you from getting that query in ITSI one way or the other. Right? So here's an example of how we go about doing that. In this case, we're looking at a set of servers here. This is IIS, so a Microsoft stack. We see IIS traffic. We're looking at the amount of traffic, doing a stats here, amount of traffic per server over the last 5 minutes, whatever its poll period was, right? And then we're going to do an event stat, right? Which is the point of this whole thing. Things like event stats and lookups and all those kinds of commands, you can use those in ITSI, right? So you can do something like an event stat to get your average traffic across all those servers. And then you can then compare every server, create that percent variance and see how does this particular server compare to my average traffic across all the servers. So that if you get something like 10% or 15% out of variance, you can flag that server and get an alert saying this server is taking more traffic or less traffic than all the others. Very powerful KPI in order to indicate that something's wrong. And that pattern there isn't specific to just traffic. There's lots of different things where you expect some KPI to be even across some number of entities, and you can use this kind of pattern to make sure that it is and flag if it's not. All right, so one of the lessons learned, as you start to monitor your systems better, and as we've done and start implementing more things in ITSI, it shines a big searchlight, and you find more things, right? And as you find more things you've learned about the application, you then have to decide what you want to do about that. So an example might be something like, now with better visibility, we noticed that at 2 a.m. the SQL database backup actually causes a little bit more latency than I realized before, right? And so now that ITSI is picking that up for you, you can make a conscious business decision. What do I want to do about it? Is it so slow that you want to stop it? You want to do something about it? You want to change it to a different time? Do you want to look at the indexing and how the job works and so it's more performant? Or are you okay with that? You want to leave it like that and instruct ITSI? You have time policies in ITSI, so you can say, here's my thresholds for this time, except for this time. Right here, I want to be more permissive or more strict, depending on what your business case is, right? So it gets really hard. The more you're monitoring your system, the more little gotchas you find here and there. At first, that's what you might consider noise, right? Because some of these things aren't necessarily impactful, but you want to then take that and learn from that, right? And then take action on it and figure it out. Either it's a problem, you're going to take action on it, or you realize that's not a problem, you need to find a workaround. And that's an example we're going to talk about here, a workaround. So we're a financial company, financial technology company, right? We have lots of traffic that comes in. And one of the little gotchas that happened is as we talked about before, we want to ensure our traffic is balanced across all our servers, but for some of our platforms, we're using sticky sessions. And that means that traffic is from the same IP, the same user, every time they come in for some duration of time, they're always going to be hitting the same server, right? And that works fine for a traffic distribution across users like us hitting it. But every once in a while, you'll have a financial aggregator. So maybe some of you use like Mint.com, or there's services like Yodlee, or companies like Finicity, right? And they're aggregating financial data on your behalf because you signed up for an account with Mint.com or something like that, right? So every once in a while, their server is going to come in, and they're going to hit our servers. And because it's the same IP, but they're going to now be hitting 1,000 accounts. They're not acting like a regular user like you guys do. They're going to hit us really hard. And because we're using sticky sessions, they're going to hit one server really hard. Now, as far as servers go, our servers can handle it. That's not a problem. It's not impactful for anyone. But it does trigger alerts like that when we talked about all of a sudden this server. So then we can make a business decision. What do we want to do about it? Our traffic isn't actually distributed across them all. Do we want to move to session state system so that we don't have to use sticky sessions and that every request can be truly load balanced across one? Or do we want to do something else? In this case, it's not a particular problem, and we decided, for aggregators, we want to, for this particular KPI, we want to filter them out. So this is something where we can make the KPI even more complex, right, by using something like a lookup table. And that lookup table, we can store like known IPs, right? Store known IPs of aggregators that that we're okay filtering them out. But it might be other things like monitoring tools, right? I don't want our own monitoring tools like synthetic monitors, our synthetic monitors to skew the amount of traffic it looks like we have, or the success or failure rate of traffic. So there might be certain cases where you want to filter certain traffic out. So this is an example, a way where you can use things like lookup tables, something that you would use in a regular Splunk query, and you can still use that in ITSI KPIs. There's nothing that prevents you from doing that, right? All right. So we've learned several lessons from implementing ITSI, and we've rewritten our whole ITSI implementation twice, right? So we wrote it once in the quickest way we could, in a way that made sense as we're starting to do it. And then things got slow. And our Splunk architects started hitting us up. What are you guys doing over there, right? And systems started getting slow. We were noticing latency, they were noticing latency, and so we had to take a look. And we were crushing ITSI, the search heads that were running ITSI. And it was because we weren't being very efficient with our searches at all. We were using a lot of ad hoc searches. Right? So ad hoc searches, well, let's talk about, so the solution to that, base searches. So what is the difference between these two, right? So if you have, let's say, 100 server farms, right? Let's say web servers, for example, 100 servers, and I want to know the CPU of all of those. I might have a search that says, for these servers, show me the CPU per server, right? And that's for our blue servers. And the green servers, we have a search that does that. And the orange servers, we have a search that does that. And the yellow ones, and so forth. And every 5 minutes, you have 100 searches that kick off for our 100 farms that are trying to get the CPU for that. But it's not just that, because every 5 minutes, we also have another 100 searches to get the drive space for all those. And every 5 minutes, have another 100 searches for the memory for those. It crushes Splunk. And it's just not scalable. So what they've done, what Splunk has done is created a concept called base searches, where you can run one heavy search, and Splunk would much rather run one big search than a bunch of small ones. And you can say, you know what, I want the CPU of every single server in my data center. Right? You could constrain it to however you want, but you could run it for, expect to get thousands of results back. For the last 5 minutes, what are my CPU metrics for thousands of servers? You get that back. And what ITSI will do for you is then say, okay, I have all this data, and I know that this service over here, that KPI, it wanted this part. It wanted the blue servers. And you wanted the yellow servers, so here's the data, and it'll split that, take that data, and give it out to the KPIs that want it. So you can run a lot of data through there in a performant way. And you also get a second benefit. It's not only that, because usually the trade-off, when you write something that's really efficient, it's usually a real pain in the ass to maintain, right? It's harder. It took extra work to do that. In this particular case, it's easier to maintain because now it's consolidated. Now if I need to tweak that query for any particular reason, I don't have 100 different places where that query exists. There's one base search, and I can go there and tweak that to improve it if I want to in the future. Right? So we rewrote everything to use that, and everything was much faster, and we were able to onboard more things into ITSI because we gave up some capacity, gave some capacity back. Another thing that we ended up finding out later is the use of service templates. All right, so service template is a concept of like if I have several services that really use the same kind of KPIs, I'll keep going back to the same example, tier of web servers, right? All the web servers, I might have different sets of web servers, but in general, they're all the same. They're relatively the same. CPU, memory, response time, failure rate, all that kind of stuff. I can create a service template with all those KPIs, even some default thresholds and everything. And now when I set up those other 100 services, I can inherit from that service template. All right? So the great thing about that is you can, it saves you a bunch of time, right, for not implementing the same KPIs over and over again and fat fingering things and copy and paste errors. You have these all set up the same, but it's even more powerful than that because you can also go back into that service template later, add a new KPI, and push that out to all the services. So say there's a new metric that I care about for all web servers. Create that new KPI, you can push it out. You can delete KPIs from there. You can change the default thresholds. In addition to that, on the other side, from the services, you can also make some changes. You can say, this service is just like this service template, except I actually don't care about this KPI in this particular case, and delete that one without breaking its link from the service template. Right? So this service is just like that one, except I don't need this KPI, and I actually do need this extra KPI, and all the thresholds are actually completely different than the default. You can make all those changes from it and still be linked back to that service template. Okay? So what that means is when you do change that service template, you have a lot of options when you click save about how you want to push that out, and optionally, do you want to override various options? You get a lot of options, but it's a very powerful concept. And that's how you achieve some scalability when you have hundreds or thousands of clients and you can't maintain each one of those individually, right? You can do things through service templates, right? All right. So one of the gotchas that you might have there is when you're using something like service templates and those base searches, of how would you use that query I was showing before, what you see above, for making sure that traffic is balanced across all our servers. How do you make a KPI like that scalable? How do you turn that into a base search? Like it was written to see if, based on a set of servers, if traffic is balanced across each of those. How do you do that? So here's an example of how you would achieve that. So instead of searching all the servers, the blue servers case, instead we're going to search all our servers, right? So not just the blue ones, now we're going to search all our servers. But now since we've done that, we need to make sure that we're comparing the average traffic to only for that particular block. So we need some way of defining which server farms, are distinct from one another. So usually in your cases, for data centers, you're going to find that your server names have some sort of naming pattern to them, which can either be identified, usually some sort of regular expression, or in this case, I've used a substring to pull the first part. But you can either use regular expression or substring, or in the worst case scenario, let's say your servers have, in a farm have no relationship to one another as far as naming convention. You can't easily get them that way. You could at least use a lookup table. Say server 1, X, and Toby are all part of server, group orange, right? Do that lookup ahead of time, and now you can use this. So now that you've identified which servers are part of the same tier through some sort of extraction there, now you can do the event stats and include that tier name, right? And that'll get you a set of results that look something like that, where it's identified, you have each server there so there's 2 different farms there. Each farm has its own average for traffic in that farm, and then every server there is comparing. That allows you to have that powerful, and it gets started, you get complex KPI, right? Especially as you think about filtering out aggregators and stuff like that. And you can still use it at a scalable level across your organization. All right, so talk a little bit more about service templates. I really covered most of service templates anyway. I'm going to spare you guys some additional detail in here where we get into really nuanced stuff that I think we'll save. You guys can come talk to me later if you say, you know what, I didn't have enough detail. I want more detail, and come talk to me afterward. Let's talk about the coolest part of all this. We'll talk about some custom alerting. All this stuff doesn't matter if you don't get all this data, this important metrics to the teams that are responding to it, right? Your support teams or your monitoring teams, whoever it is, they need to have this information. When a problem happens, they need to get it, right? So one of the things that we've found with ITSI is that while it does an amazing job of going through a lot of data and getting that information for you, but on the alerting stuff, it doesn't quite handle all the use cases we need. We have a lot of complex use cases, and you shouldn't have to make compromises in your use case and say, well, this is the way ITSI does it, so I guess we'll do it that way, right? There's out of the box with ITSI, there's a lot of options you have there. I encourage you to play with it. It's changed over time. I encourage you to play with it and see if you can get it to do what you want out of the box. But we added a lot of requirements of things that we wanted to do, and so we need to do something custom, right? So the great thing about that is that you can. With ITSI, every time it runs its poll for your KPIs and gets that data and displays that information to you, either through the service analyzer screen or a glass table or whatever it is, that's all data that it's stored there from its previous searches. So it'll run your KPI, get the data, and it doesn't just throw that away. Like every time you look at the service analyzer, it's not getting all that historical data fresh again. All it's doing is getting the metadata that it stored from the time it did pull that, right? So every 5 minutes or 1 minute, however you set your thresholds, your intervals, it gets your CPU, and then it stores that rolled up data in ITSI, right? So you can make use of that same data. Everything that you see in the glass tables, the deep dives, the service analyzer, all that data is basically a summary table, a Splunk summary table that you can already that you can start using, right? So all that data is searchable in Splunk, and this is what it looks like. Right? It's a lot of detail there. The index is ITSI summary. And it has a lot of detail in there. And you don't really need all of it, but feel free to make use of whatever interests you. But you see the key points in here that are highlighted. One is the name of the KPI. There you see it's CPU. Has the service ID. And that's important because one thing you will see that it's not in here is the name of the service, a friendly name. You just have an ID, right? So we'll address that here in a minute. And we also have the value. So the alert value is actually your CPU value, the value of the KPI. And you also have the alert value. So based on the thresholds that you've set, are in your good? Is it your warning? Your low, high, and critical? What phase? What color is it? Based on the thresholds that you have set, right? You have this not only for each KPI, but your service health, right? So you have in ITSI, it aggregates this data. You have your KPIs, and then it also sends that data. You have an aggregate for your KPIs, and then you also have that roll up to a service health, right? And so all that data is available in here, in that same index. So what does a pass of this look like, right? So here we're just querying that index. We're saying in this case, we don't want to see the service health. We really, in this particular case, for our requirements, I care about the KPIs, right? ITSI will use weights in different systems to determine the health of your score, the health score of your service. I'm more comfortable dealing with my KPIs directly. Are my KPIs green or red and not this calculated health? A little less comfortable with that. I like it visually, but that's not going to be and that's good for our support teams, but it's not what I'm going to alert on, right? So I want to see the KPIs. So filter out the service health score. We also obviously don't want any disabled services right there. So give me the latest, show me the latest values for all that stuff. And so you can see something like this. Now I could just take that right there. So where do we do this, right? Where would this actually be set up? This would be set up in classic Splunk, right? So this part here, you've set up everything else in ITSI. ITSI is doing these calculations, storing the data in Splunk. You can then do the special alert in core Splunk, right? Do this search, right? So then you can email those results out. It might be look something like this, where we've hidden off that other ID field. I neglected to mention, but you probably saw it on that last, I'll go back. On the bottom there, you see that lookup. That's a built-in lookup that ITSI has that will do that mapping from that service ID to the friendly name, right? And that's how we have that service name on the end there, right? So you don't have to maintain anything. It will handle all that stuff for you, right? So then you have an email like this, right? So here, this doesn't make sense because you have some things that are good. Why would that be an alert? But it's just an example of data, right? So now your support teams can get an email that has all this information. All the problems that I'm having right now are in a single email with the service that's being impacted, right? The KPI, the name of the specific KPI, like CPU or memory, right? What server it's specifically happening to, if it's specific to a server, what the current value is, and how bad is that based on that. And your teams can get that kind of alert instead of having those be 4 different alerts that maybe go into 4 different teams. And when they get that, depending on on your system, it might have, it probably has the server name, but does it have the specific value? Maybe it does, maybe it doesn't, depends on your system, right? So we have everything we possibly want that our teams could pretty much respond based on that alone, right? But we want more, and this is, we kept adding more requirements because this is what our business needs. There's a couple different things you can do here. What if I want to know not just about what's going on right now, but what was going on a moment ago, right? Did this start as a sharp spike? Or was this something that is built up a little bit over time to now it's past our thresholds, right? So what if I want not just the current alert values, but I want the 5 minutes before that, or whatever your polling period was, right? So in this case, we're just doing our search a little bit longer. Before we were searching back 5 minutes and saying, giving us the current value of all our KPIs. Now we're saying go back 10 or 12 minutes, and I want to see the last 2 values of my KPIs, right? We go back 10 minutes, we pull that value, and then all we're doing here is just splitting that data up and saying, hey, if it's data that was from the last 5 minutes, then we're gonna, that's gonna be called our current data. And if it's from 5 minutes prior to that, then we're gonna say that's our previous data. We're gonna split it up like that. From that, then you can have alerts that look something like this, where now we have our current values and our previous values, and that's even more context and information for our support teams to look, because it's obviously a different kind of scenario, something that built up over time, or if it's something that just started, right? And another thing you can do with this, right? Now that I have this kind of information, I can make a decision like, you know what, this system might be noisy or something, depending on how, this is all options for you guys, but you could also choose to do something like, I only want to alert if that KPI was actually over the warn threshold for those 2 consecutive periods, right? So you can see here, you can see the top one was critical for both periods. We definitely want that. The next one was medium and high. We want that one too. But that other one was good and medium. Maybe I don't want those, right? So if a KPI, maybe you have a situation where, depending on everyone's system, maybe every once in a while you have that sharp spike for something, but it's going away and you have your support team chasing ghosts. Or the support teams get annoyed. Why does this happen every time we look at it? There's nothing going on. It's not a true issue. I'm tired of spinning cycles on that. If you wanted to, you could implement a system like this where you could say, I only want to notify my support team if the problem not only happened the current block of time. Remember, in ITSI, you can set how frequently you want those KPIs to run, right? You can have it run every minute and say, only if those 2 minutes, only 2 minutes in a row, 2 periods in a row, if it's still over threshold, all right, now I want to alert, right? Not immediately. Let's give it a little moment. And that's one way of reducing the amount of noise for your support teams. All right. So one other thing, this one a little more complex, and we're almost at the done of complexity. We're almost done altogether. Is the maintenance windows. Maintenance windows it can be a challenge. And ITSI does support maintenance windows, but it doesn't support recurring maintenance windows, right? So if you know a certain time in the future I want this service for this date in the future between this start time and that start time, that's maintenance. ITSI knows how to handle that and will do that. But one thing ITSI doesn't do is support reoccurring maintenance window, right? I want that maintenance window every Sunday from 1 to 2 a.m. for that particular service, right? It doesn't do that. And there's a couple of different ways of getting around that. I'll say the easy way, meaning the least amount of technology, but not a short query. In fact, I'm not going to go into the entire query, but I'll show you kind of the steps it does. And also, at the end, you won't see it here, but later on this presentation will be made public, and all these queries, you guys will see all this stuff. And the query that we actually use for alerts, you can see here. There's nothing proprietary about it, that it's in the presentation, but it's far too much, so it's just pasted in there. So you guys will have that if you want it. One way of doing this is by lookup tables. You can see we've used a lot of lookup tables, but one option here is lookup table. If I have a column, it's the name of my service, right? Some other columns that are the start and stop time of that in like a 24-hour period, 20 military time, right? And then I have the days that's in maintenance. I can then write a query that takes the current time, between any of these. So ignoring the rest of ITSI, just imagine a query where we pull all the data from here, and then we're checking for every row here. Is the current time, is it currently that day? Am I in one of these days? And is it within that time window? And if so, for every one of these rows, it's going to set a flag to 1, yes, we're in that maintenance window, or 0, we're not in that maintenance window, right? So you have that. Once you write a query that does that, you can then take that other alert query that we had and join the two together. And now for every KPI, for every service that's there, you've joined saying whether that service is in maintenance. And once you have that data there, you could then say, all right, if that service is in maintenance, filter it out, right? So you're able to do that. That's the way we're doing it now. We actually are looking into doing it a different way, a little bit more complex. This can all be done with SPL, and you don't have to get more complex coding involved. But one of the things that ITSI does support is you can insert a maintenance window via REST calls, right? So if you do have an external system where you maintain all your maintenance windows, you could have a process, whatever language you want to write that in, to grab that, maybe let's say a daily process that runs. It's going to capture all your maintenance windows, determine if any of those are coming up in the next 24 hours, and if they are, then it's going to call ITSI and insert all your upcoming maintenance windows. There's a benefit to that because ITSI does natively understand maintenance windows, and it will give you a better graphical representation in your screen. It will make it blue, it'll give you a little wrench icon, and that's a benefit. But that's a little more complex and coding stuff to do. So you can do it, it's even better, but this is an easier thing to do. Just some SPL and you can achieve this. The last thing we're going to cover here is something that seems super silly, and I hesitate to mention it, except it's really powerful for us. It's just making sure that you've captured all you've grouped your services together by your product, right? So when we alert, we don't alert per service. We alert per platform, right? So a platform might be made up of several services. Of a platform, that platform is made up of a web tier, and an application tier, and a database tier, and a lot more tier, varying systems. If there's something wrong, I want to know that at the platform level. So when we talked about those alerts that we had before, that query that gets all that stuff, we're doing that search for all the services in a given platform. We're not searching all of ITSI and saying, find me all the services, all the KPIs that are having a problem, right? I want to have these things separate, right? So if I'm having, if platform A is having a problem, I want all the different services related to platform A and all its KPIs to be captured in one search, and that's one alert to go out to a team. Platform A is having a problem. It's these services with these KPIs, right? Platform B is having a problem. I want to have that being being separate. So that's something that can be simply done via naming convention, right? So if all your ITSI services have a naming convention where, where you have, you start off with that, with some kind of commonality for all the services in the platform, start with this particular name, and then at the end you have a hyphen web tier, hyphen database tier, right? You can do that. So adding that where clause to the end for doing that is super powerful and making sure that your support teams have all that context and not getting a ticket that's got like 3 different unrelated platforms together in the same one. You keep your platform separate. All right, so let's recap here. So again, don't limit what you're trying to do in ITSI. Don't sacrifice anything. Don't make compromises. If there is an ITSI, if there's a KPI, there's some search that helps you understand is important for you in the health of your platform, you can get that into ITSI. So it's just figuring out what is the way, what is the mechanism to do it, because it's possible, right? So also make use out of entities and not just the built-in entities, but dynamic entities. Whatever you want to split on, feel free to do that, right? Make sure to improve both the performance and the maintainability of what you've built out by using base searches and service templates. It's going to save you a lot of time, right? Not just, it's going to save you a lot of time, not just in maintenance, but also when you've had so much time sunk in the maintenance that you rewrite it anyway, right? Just cut to the end, set up that stuff in the beginning, right? And then the possibility of using custom alerts like this, so that you can implement complex and custom procedures and requirements that support your business needs, because you can do more things than that. Whatever you want, all that data is available to you in that Splunk index. All right, so that covers everything I had today. Open the floor to questions. Yes.
As you look through your ITSI summary and you can see when things change state, can you try to do availability statistics out of that?
So the question was, are we creating availability statistics based on the data that's in there? We're not using it that way. We have other monitoring systems that are like synthetic monitoring that's constantly hitting the site. So we use other systems to achieve the same kind of things and figure out availability via synthetic logins that are accessing the site. But also the KPIs itself, you can consider, it does have, ITSI calculates service health based on your KPIs, right? So you can also, it'll kind of out of the box try to do that for you. The way it kind of works, you don't have 100% control over exactly the weights you give everything. There are some sliders, but the way the math works out, the way the math works isn't perfect, but we don't do that today. Yes, sir. Question was, do we have any remediation based on the alerts that we have, like automated remediation? Not today. That's something that some people in the back of the room are helping us out with right now, of getting this system with all this data. Now we just need to pipe that out to some kind of automation tool to say, hey, this KPI for that. So we do have automation that works separately, independent of ITSI, that in some cases is kind of doing double duty, where it's looking for the same kind of problems via an additional mechanism, and then it will take action. So we do have automated remediation, but the two systems aren't linked. What I'd love to see in the future is have the two systems linked, so we're not maintaining two different kinds of searches for the same kind of thing. Yeah, the question is, I think, do we use a base search even if we're only having it for one?
So you meant, like, the example you showed, it was like for variance or something like that. Mm-hmm. I saw like one metric out of that. Now what if we have?
Oh, yes.
Like 5 or 6 different metrics?
We have some that will do 12.
How do you do that? If you use stats, it's like hit times the macro.
So the question is, like, for a particular base search, can a base search just produce one result? So for example of that one was, the percent variance. So you can do that. Whatever field you have as an output, so I created a field there called percent variance. But you could have another field that was, there were other fields in there that were in that output. There was the total count volume, right? So just having that field there, you can, in ITSI, you could say, this field, that's one metric, this other field. So if you have calculate other fields, you can do that. And we have one for there's a lot of data you can get from like ITSI, from from I was saying IIS, from web logs in general, right? There's so much to be learned from those logs. So we have one base search that churns through that, and the search itself is just line after line. But it's performance enough because you're only searching back over the one last minute or last 5 minutes of logs, right? So running that big search over that period of time, it's not too bad. And yeah, we'll output like, a dozen or so metrics. Yes, sir. I'm sorry? Do we version our service templates? No, we don't. And it is something that can get you into trouble, being careful about what you're doing there, especially with a larger organization. If it's really possible for you, if you have 100 services that inherit from a service template, you have to be careful about who changes that service template and what they've pushed out, because they might push stuff out to your services in addition to their services, right? They might say, oh, I want to change this default threshold, but that's going to change the default. So they're not versioned. There's not really a way to do that. But I will say that, yeah, you need to be careful of those kinds of concepts because, if you make a change to a base search, right? That's the thing about maintainability, right? You've made one place to change that impacts everything. And that's the downside, right? You change that, you got to be careful about the changes you make there because it's impacting everything. No, so the question is, are we using a source code repository? I would love to, but we don't have an integration with that right now. So really it's for our most critical, mission control queries, we do have other systems where we use for taking copies of that stuff and kind of a dirty backup system for that, because it's really easy for someone to make a change like, oh, that didn't work right, I want to undo it. Wait, what was it originally? I don't quite remember what that search was originally. So yeah, we do back it up, but it would be good to have something like that. Any other questions? Yes? I missed the last part. Is there any pattern for what? Sorry, I'm not quite picking up on the question, but I'll come and talk to you afterwards, or come on up and we'll talk about it. Any other? Yes? Good question. Is ITSI everything we need, or do we need more? We definitely need more, and we do use more. So for instance, we talked about the network monitoring. We have different tools that are capturing network traffic, but we send all that data to Splunk. We have some tools that are doing synthetic monitoring. It sends all that data to Splunk. So we have a series of other type of sensors and monitoring tools. It doesn't, this is the mom for us, the manager of managers, right? Other tools are capturing data, but we don't want our support teams to have to go to all these different platforms. So all that data is sent into Splunk, and we use it there. Question is, can Splunk capture that data? Not in some cases it can, but in most cases the way we're using it, no, it's not going to be able to capture network outbound network data and things like that, or do synthetic logins and things like that. Yeah. Yes, sir.
If you have service dependencies, where are you defining your maintenance windows? Top of the hierarchy or every service?
So the question was, if we have service dependencies, how are we setting up our maintenance windows? For the system that you saw there in place there, you need to set it per service. So if you have a platform that's in maintenance, and that's going to impact 8 services, you can't just do the top one. You do need to specify them. At least the way the joins are working, you need to specify each one. And that's a good question, because I think even out of the box with ITSI, if you're using the built-in one, I think you still have the same problem. I don't think it will know that all the services in the dependency chain also count as being in maintenance. Yeah. Yes, I'll take one more question, and then we're kind of out of time. We're going to be booted out of here. So come see me afterwards, and I'll step out, and we can speak in the hall. Yes, sir.
Sorry, real quick. Any experience with data that lags and advice about how to deal with that, like IoT devices?
Yeah, the question is, what if data lags? That's a complex one. We have had that sort of issue, and we've had to play with some things where, something is running, running every few minutes, but by the time it gets into Splunk, because it's coming from an external sensor, it's a couple minutes old. Now it's starting. So there's no simple answer for that. There's not a quick workaround. It's mostly working with the teams to see how you can reduce the lag. There are some things you can do to work around, but I don't have any kind of advice to say if you do this, you're going to address it. A lot of it is just working with the teams to see if you can reduce that lag. All right, thank you guys for your time today. If you guys have any more questions, I'll be speaking outside.